Good morning, everyone, and welcome to today's webinar, The Growing Threat of Lithium-Ion Battery Fires, Prevention, Protection, and Preparedness. Lithium-ion batteries are known for part of almost every aspect of our daily lives, from our homes, personal devices, laboratories, infrastructure, mining, transportation, energy storage, and so much more. Today, we have the two industry experts joining us to share their experience and insights. I would like to welcome Cobus Stradrell, owner of FIRELAB with more than 40 years experience, or like you just mentioned, actually 50 years experience in a fire safety, engineering, and industrial fire protection. Thank you for joining, Cobus. And also, all the way from Germany, Marius, Regional Sales Manager, Global Markets, and from asecos, our supplier for all the asecos cabinets, fire safety cabinets, and lithium-ion battery cabinets, with more than 60 years of experience in the hazardous materials and storage and safety industry. Thank you both for joining us and sharing your expertise. And thank you everyone for joining us, taking the time out of your busy days. We know that you're busy, but we know that you would definitely benefit from this webinar today. If you have any questions during the presentation, please feel free to join, to put it in the comment section, or just maybe raise your hand at the end of the webinar, where Cobus and Marius will be more than willing to answer any of your questions. Okay, with that, let's get it started. Cobus, it's over to you. Thank you.
Good morning, everyone. Thank you for joining us. I mean, this is a new thing, lithium-ion batteries. It started small, but it become more and more a issue, and that's why we have the opportunity of sharing with you. Just to bring you in the picture, if we're talking about lithium-ion, we're not going to cover everything, because if you can break it up into sections, it'll probably be residential, commercial, and industrial. Now we're going to focus more on the one which is affecting the public in general, because commercial and industrial is normally carried by professional teams, and they know what they have to do about it. And it's also very important, and I think very few people have seen or have been involved in what a lithium-ion fire or what the lithium-ion danger is. So what we'll try and do during this presentation, not to spend too much detail on technical issues, but rather be practical and give guidance to the normal public. Should it be necessary to do something on residential, commercial, and industrial, I think that should be a different talk altogether. Now, if we look nationally in South Africa, currently we're in a process of looking at regulation and specification for lithium-ion battery use in South Africa. There's nothing currently on the way. And we've also identified there that we will first focus on residential or things that affect the general public, rather than going into commercial and industrial. And once that is done, then we'll move on further. If we look internationally, what is available, and I had a scan there and I went down to have a look and see what is available, starting off with NFPA, which is most people know NFPA. And there you've got NFPA 55, which is basically covering the whole spectrum of lithium-ion, from manufacturing down to installation and maintenance. But it's mainly focused on battery energy or energy systems more than 20 kilowatt hours plus. So on the smaller side, we've got a problem. You can apply that, but it's not normally the same rules to apply, and you've got to be more meticulous about how to handle it. Now, if we look at it also on the American side, then you've got the Underwriters Laboratory, UL, which is 9540. 9540 is covering the testing, and also the UL 1973. That is testing. And then you've got, if we go further, then we go down to the German, where Marius is coming from, the DIN EN 50521, and also DIN VDE 0126-3. and then EN 62093 and VD 126-20, and then EN 61427-1 and VDE 0510-40. So there's a lot of in the European market which is covered by these regulations, but that is not for us, and that's on the smaller side. Then if we look on the commercial side, just to mention, you've got the IEC, which is 62619, which cover electrical test, mechanical test, and environmental and thermal test. That's basically on the battery side. The road vehicle traction batteries, that's mining and vehicular appliances. Then it's covered by the IEC 62660. Industrial settings for ES battery safety standards is covered by IEC 62619. This code defines electrical, mechanical, and electrical and battery management BMS systems. Then on the portable consumer side, that's where the small appliances comes in, like the e-bikes and whatever. That is into the hands of the general public. It's covered by IEC 62133. And those mainly concern or regard power tools and consumer electronics like computers, etc., whatever the case is. Now, if we look at all these standards, now we can say which are the important ones for energy storage systems. So we've got to look at UN 38.3. That is mainly meant for transportation. So that means bulk transportation of these batteries. In UL 1973 for United States and North American projects, that's more on the industrial sides. And then UL 9540 for ES certification for battery systems. And then if we look at the European market, we look at the CE-related compliance, for the European market. You'll find it in there. Okay, I think that is enough on the standard side. Now let's go into the heart. Why lithium-ion batteries fires are increasing. It become more and more a concern as an alternate energy source. Whether it's a remote or a rural area, sometimes you're not serviced by electrical lines or whatever, but at least you're now put in a position where in the past you didn't have electricity. You can switch over to a PV system, and all PV systems goes with batteries. Otherwise, you can have direct, but then you only got sunlight to operate your system. So in most cases, a PV system will be linked to a battery system. And then also from a cost point of view, if you're far remote and you have to get a line and being serviced by your power supply, it can cost a fortune, because first you've got to have a line coming in, you've got to have transformer, are you the only consumer or whatever. So the cost is very high to have that. So by installing a self-contained system like a PV system and a battery storage, you're completely independent and you can function. The other reason why it's increasing, there's more and more installations, increase in installations. Now, normally increased installations demand is very often in advance of regulation, because it's something new that's coming in. You're not geared for it, and then the people do installations. It could be, and every Tom, Dick and Harry is now an installer of a PV system, and that is a major issue, because it's got to be done correctly. Otherwise, it can be a problem. And then the last one, I say, lack of regulations or a specification. Now, as I said earlier, if you talk commercial and industrial, there's a professional team that's handling it. But the general public, to supply and demand there, there's very limited specification with regard to that. Okay, next one. Why it is increasing? It's all statistics from actual installations. If you look at the statistics, and the Germans done a very good report. They've done, TUV Rheinland has done a very comprehensive report, which is based, I think, on 1,300 causes of fires associated with PV systems, and they've identified 34 causes there. And I'm only going to mention the first three. Design. That's very important, that the system gets designed correctly. Design means that if you've got a PV panel, there should be certain ventilation requirements. There should be control over, the size of the setup of the installation, especially when it's on top of roofs. The installation, very important as well. They try and do it cost effective, especially in the absence of regulation. They may use not the correct equipment, like too thin cables, for instance, or incorrect cables. Because if you take the system coming from your PV system, that's live as long as the sun is shining, so it can't be switched off. So it remains live. And then people put it in ducting, and that doesn't make protection for that. And we're working with DC power, which is something completely different to AC. And arcing is a major thing there. So installation and whatever you do there, it must be 100% correct. And then selection of materials. People think a switch is a switch and a connector is a connector. You've got to be very cautious that DC switches and components are completely different to that of AC materials, and that is on the course to prevent any arcing or short circuit during the whole system. And then energy management. That is also important. Most of the combined systems that you get in a public domain is normally a compact unit. It comprises an inverter and a battery combined. Now, that's got a battery management system in there. Now, it's good to say it's got a battery management system in there, but it's got to be maintained to function properly, and it must be checked whether it's still functioning properly. Because if the battery management system is not correct, it can result in a major problem. Another thing also on the energy side, talking about, and that is going back to selection of materials as well, very often people apply the cafeteria system where they select an inverter and they use a different battery. Now, if you install a system, you must use an integrated system, because otherwise your battery management system will not function. Okay, next one. General understanding of lithium-ion batteries. Lithium-ion battery, and I mean, I've got a perfect example here, which I quoted earlier. I just came back from a rural trip into the wild, and I had to use battery support for my fridge at the back of a bakkie. Now, the people convinced me to use a lithium-ion battery, and I said, no, I don't want a lithium-ion battery, rather give me a deep cell acid thing. And it resulted, because of the condition of the roads, it resulted in a short circuit, and I've got a minor fire, but I'm still driving my vehicle. I was able to drive it back. People that I know about also during the same time utilized a lithium-ion battery. Now, lithium-ion battery, you've got to think about it, because of the dangers, it's got to be contained. Now, having a lithium-ion battery in an uncontained area like they had, they lost the entire vehicle, and they've got stuck along, a desolated road for 7 days before they were picked up by somebody else. Now, lithium-ion battery consists of cells. And the cells is a makeup, depending the capacity or the unit or the module or whatever, it's constructed from a number of units in there. And then it's packed together depending on the demand or the size that you need. Now, the composition of that consists of, a number of units that's going in there. First, you've got containment or packing of the cells, and you've got connections, whatever. And finally, it comes into the final project, which is in a console. Now, that console is closed. Now, if something happened with a battery, it happens with a cell. Now, and if the cell goes wrong, and lithium-ion batteries are sensitive to temperature. So if there's a malfunction or a dry connection, which I picked up in some of the fire investigations that I do, that you develop resistance, and the resistance creates heat. And the minute heat is there, then the lithium-ion cell can become unstable. Now, there's a process that if a fire in a lithium-ion battery starts, it starts getting hot, and then you've got volatile organic gases coming off, which is normally the toxic ones, but that is before the actual situation happens. You can detect that, but you can only detect that in an enclosed environment. And once it's gone past that, and that cycle could be maybe 20 minutes or so, or even more, then it can result until the critical temperature is reached, and then the cell becomes reactive. Now, because the battery is consisting of a number of cells, if one cell is going wrong, it starts heating up the next, and that is where the thermal runaways start. And it's not like an electrical fire in a lead acid battery, make a short circuit. Once a short circuit, it's off. That thing remains constantly, and it's growing, and it's setting off cell by cell, and that is where the thermal runaway normally started. And to be able to detect that, you need a confined area. Now, this is not the purpose of the whole speech, but there's a lot of people, especially in the general public, selling fire extinguishers to extinguish lithium-ion batteries. But you cannot extinguish a lithium-ion battery because it's in a console. You can only do that if the cell, the small component, is exposed, and you can apply directly onto that. So you cannot, on a normal battery, which is in a metal container or a metal box, you cannot reach it. So you cannot put it out. You can maybe cool it a little bit and protect the environment, but you cannot do that. Okay, next one. Next slide. These are tests that we've done here. The reason we use a small battery, the batteries that we used here was for a model plane. I think it's less than 600 amp hour battery. And you can see the window there. It's a 600 by 800 window in our test cubicle. So what we've done is we've overloaded the cell, that battery, and you can see when the thermal runaway started on that cell, you can see what it's like. To judge the size of that battery, after that, that's placed on a brick, which is 115 by 200 by 200. You can see it's smaller than a brick. That is the remainder of the battery, but you can see the impact of that. Now you can imagine if you've got the normal battery, maybe a 2.5 kVA battery, which is normally at least one of the batteries that you use for a residential application, may contain 36 of these cells in that battery to give you that output. And you can imagine if that thing goes into a blaze, to see what the impact of that would be. The next slide. There is where we tested something with an extinguishing medium in there, but you can see it's tested inside the box, inside our test cubicle. Now, the size of that box is about 300 by 400 by 300 deep. So it's a very small box, and it's got the same battery in there. And you can see on the left-hand side, when thermal runaway started, you can see what it looked like, and then it was extinguished because it was contained. So containment, if you want to address the risk of lithium-ion batteries, it started with containment. But so that's a very important aspect. Next one. And what are the biggest risks? You've seen from that picture, the heat of combustion. If you've got a lithium-ion battery, you can measure temperatures up to 1,000 degrees easy. But that's not the only thing. You also got the products of combustion coming off there. Now, that is nitrous oxides and fluoride gases or whatever. And the other problem is that if you contain it, you must also be prepared that you can have an explosion of these gases. So there again, that heat of combustion that you've got to address if you want to consider, the extinguishing of a battery. You've got to look at that. You've got to know what you do with the product's combustion, where it is, and then explosion. Now, these aspects are important to know. Where do you store it and where do you sit it, or place it in an application? My biggest problem I've got currently is that, it's a new thing in South Africa, and I don't know if that same apply for overseas, a little bit longer there. But nowadays, everything is on an application which is on a cell phone. And the people try and put it inside a living area where they can impress friends, say, look, I'll switch off this, that, and the following. So the inverter battery combination is in a living area. Now, look at the dangers that's associated there. You don't want heat in your living environment. You don't want the products of combustion there, and you don't want an explosion. So if you look at the battery storage or the energy storage system, it needs to be separated. And the only way to separate that is put it outside or put it in a suitable cabinet, what it's all about, which can handle these products, heat, combustion, and explosion. So those are the main issues that you need to consider. So if you plan using a battery in any environment, I mean, you've got to look at the fire behavior, and you look at the aspects that we've discussed there. And one of the things is to detect it as quickly as possible. Now, you can only detect VOCs or volatile organic compounds, you can only detect in an enclosed environment. So you need a cabinet, or you need something there to give you sufficient time to detect that, to allow evacuation should it be necessary, or to investigate what's going on. And remember, once you've detected any gases coming off, you've got a maximum delay of about 20 minutes before the reaction of the battery starts. So that means then you've got to do evacuation. Now, evacuation, and if it's contained there, like I've showed in the test that we've done, suppression is very important. But there again, suppression can only take place in a closed environment. Otherwise, your suppression medium is not right. And then if a lithium-ion fire started, I mean, the first thing you do is emergency response. So communication as quickly as possible to let somebody know. I know about an incident that happened, and it was addressed on a seminar earlier this year, where a e-bike had a fault and started burning in the house. The husband quickly, when it started there, he took his whole family out, and he had a fire extinguisher, a lithium-ion extinguisher, which was sold for that purpose, and he went back into the house to extinguish the fire. And he didn't come out. Luckily, the mother phoned the emergency response, and when the people came here, they found him. He was capacitated, and eventually he died because he was exposed to the combustion gases coming off there. So one thing which is important here, in that is contain, and to contain it, but you must also allow for expansion, for explosion, so there must also be proper ventilation in this case. Next one. And I think that is the end of my slide. So I just want to sum up, and I said earlier, you can sum up safety with lithium-ion batteries. It can either end with 4 words, 8 or ion, and which is lithium-ion, and that is, isolation, ventilation, evacuation, and communication. So to alert the fire department should something happen. So if this is the only thing I can convey to the medium here, or the people that's listening in, be careful where you've got to try and isolate your battery for your family's sake. And if you can't put it in a cabinet, at least put it outside, and you treat your storage system as a plant room with proper fire-resistant walls, which can cater for the risk that's been associated. Thank you.
Thank you, Kobus. Marius, over to you. Thank you.
All right. Hello, everyone. Kobus, thank you very much for these very interesting insights. It's always a great pleasure to listen to you talking about standards and recommendations. Yeah, before I start, I would like to shortly introduce company asecos to you. The name asecos stands for Approved Security and Ecology Solutions. And as you can tell from that slide, we are into the development and the manufacturing of safety storage solution within facilities. It all started back in 1994 when we developed the very first cabinet for flammable hazardous materials that can withstand a fire for 90 minutes of time. Back in 1994, it was just one cabinet. Then we developed the European standard with 90 minutes fire resistance out of it, which is still state of the art. And today we are looking at more than 300 different cabinet types with many thousand interior configurations available. The basic idea, however, is still the same: to contain hazardous materials within facilities safely and protect staff as well as environment in handling those substances. Next slide, please. Yeah, talking about hazardous materials, I mean, probably we all have seen those GHS pictograms here. GHS stands for Globally Harmonized System for Classification and Labeling of Chemicals. This system has been introduced in 2003, and that was the very first time where there has been, as the name indicates, a global perspective on how to classify and label hazardous materials. Next click, please. You might wonder, isn't today about lithium batteries or not? Yes, it is. And as you can tell, also a lithium battery is not classified in accordance to the GHS as such. But as we have learned, there's absolutely no doubt at all that a lithium battery does contain of hazardous characteristics. Next slide, please. I have a statistic here from UL. This is covering the North American market. And on the left-hand side, at that column chart, you can see the number of incidents arising in contact with lithium batteries over the years. And you can see that there is a massive increase in incidents related to lithium-ion batteries over the last couple of years. On the right-hand side, in that pie chart, you can also see something very interesting, which is the problems that are reported by these incidents. And you can see that most any of those incidents are related to a fire. So a lithium battery is, under certain circumstances, a fire hazard. Next slide, please. Obviously, those kind of incidents do not occur solely in North America. Here is an example from South Africa, from the Standard Bank. A fire occurred there at the beginning of the year in that battery energy storage system they had in the container. It contained a 300 kilowatt hour battery rack system. And for some reason, that battery went into what Kubus explained, a thermal runaway. So basically, the batteries ignited themselves. Fire brigade came on site, tried to extinguish that fire with conventional measures, water, for numerous hours, but still the fire escalated further until they finally applied some fire block lithium-ion gel onto that fire to control that fire. So this is all pretty serious, right? And the question is, are we the only ones who know something about it? Are we the only ones who are aware of any potential danger? What is it that insurance companies say to that topic? Well, insurance companies, they have very clear statements. They say, if lithium-ion batteries are required at production facilities, then measures and safety precautions, such as storing them in fire-resistant cabinets, should be considered. They say, in order to ensure effective loss prevention, however, lithium batteries can be used with conventional protective concepts involving classic measures proven in manufacturing, handling, and storing flammable hazardous materials. They say lithium batteries should generally be treated as a hazardous material. They also say areas with medium powered batteries should spatially, at least 5 meters, or structurally be separated from other areas with fire resistant structures. So again, those recommendations from insurance companies are very clear. Battery distributors, so for instance here Bosch or Stihl, what do they provide as an information in the user manuals? Well, they say an e-bike battery must never be charged unattended. Use of unauthorized charges can damage the battery and result in fire, explosion, and personal injury and property damage. They say never leave the battery tool unattended when the battery is inside. Do not charge unattended or leave a charged battery pack connected to the charger. If storing the battery in the charger, disconnect the charger from the outlet. So also they are very clear with their recommendations. So the question is, what does that mean for us, right? In the end, it means that the responsibility lays solely with you, because the insurance company says you have to treat a lithium battery as a hazardous material. The battery distributors say you cannot just charge your batteries unattended. And ask yourself, when do you charge your batteries? Do you charge them during the day and you supervise the charging process, or rather do you charge them during the night? I mean, hand on the heart, we at asecos, during the day, we manufacture our cabinets, so we use power tools for that. During the night, we charge our batteries because we need them the next day. But this is exactly what we are not allowed to do when it comes to the user manual of the battery distributors. So also have a look into the user manuals of your phone or laptops or any other battery-driven device. You will find something similar in the user manual. Again, in the end, this is on you. So what results out of that knowledge? Well, the first step towards safety always is to carry out a so-called risk assessment. A risk assessment can follow the so-called STOP principle. S is the first thing, stands for substitution. So basically replace that hazardous battery against something which is not a hazard. I mean, in theory, all of you, including us, could return to a handheld screwdriver, but probably for the sake of efficiency, and since everybody is using a power tool nowadays, this is just not convenient to just get rid of all our lithium batteries. So what is it that we can do? The next thing that we can do is go for T, which is a technical measure. And this is exactly where we, Lasec, as well as asecos, can come into place. It all started back in 2018 when we received more and more requests from end users asking us for help with the new hazard lithium battery. Why do they came to us? Well, back in the days, more and more fires related to lithium batteries occurred. Insurance company told them, please do something about that. Treat lithium-ion batteries as a hazardous material. A battery is a fire hazard. We as asecos, being back in the days almost 30 years in the market of fire resistance enclosures. So this basically is why we received so many requests from our customers. And so then we gave it a thought. What is it that we must do in order to transform our typical cabinet for flammable hazardous material into a cabinet that can accommodate that totally different risk for lithium batteries? We came up with the following ideas. Next slide, please. The first characteristic a cabinet must have in order to accommodate that risk is fire resistance. We're speaking of fire resistance from the outside to the inside, so fire exposure from the outside for at least 90 minutes of time. This is basically what we can accommodate with the European regulation 14470 part 1 that proves 90 minutes fire resistance from the outside to the inside. Those cabinets fulfill the requirements of the separated and structurally fire resistant storage area that those property insurance companies would like to see. Next slide, please. Obviously, we cannot just claim to have a fire resistance like this. No, we have to undergo very stringent testing. This here is a fire chamber at the independent testing institution at the one slide back, please. At the MPA, thank you, at the MPA in Dresden. And this is a fire chamber. You see the cabinet is placed freestanding inside. The doors of the fire chamber will then be closed and the cabinet will be burned from all sides with more than 1000 degrees. Inside the cabinet, there are everywhere temperature sensors that detect or review basically the temperature increase inside. And so we can ensure that our cabinet provides 90 minutes fire resistance from the outside to the inside in the event of an emergency. This is state of the art and considered the highest safety standard there is on a global basis. Next slide, please. The question is, though, having a look at this video here with the scooter, is a fire resistance from the outside to the inside really sufficient? Well, you see there is a problem with the charger. They disconnect the scooter from the charger, but as you can tell, the damage is already done. So was it a fire that caused that battery of the scooter to go into a thermal runaway, or was it the battery itself that poses the fire danger? And I guess we can all agree that it has been the battery itself, right? So next slide. This is why it's so important for us, and we thought about that from the very beginning, that we to not only have the fire resistance secured from the outside to the inside, no, but also from the inside to the outside. And so basically it was clear for us from the very beginning that the dangerous situation is a different one. It's not a fire hazard from the outside to the inside that lets the battery go into a thermal runaway. No, it is the battery itself that probably will pose the fire danger. And so we wanted to ensure that the cabinet can also accommodate that fire that probably is happening inside the cabinet for at least 90 minutes of time, which is why we have tested our cabinet also in accordance to another European regulation, which is European norm 1363 part 1, where we proved a fire resistance also from the inside out. We carried out the test while removing the back wall of our cabinets, and so basically we put them into a fire chamber and burned them from the inside to the outside. As you can see at the front of the cabinet, we have numerous temperature sensors that also detected the heat increase at the outside. And we also used cotton and moved that cotton from the top to the bottom, always at the middle gap of the cabinet, that we can see if any heat, any spark or something like this is escaping out of the cabinet. And so we could prove also a fire resistance from the inside to the outside. Next slide, please. What also is very important is the alarm detection. It's 90 minutes. It sounds like a lot of time. But again, when do you charge your batteries? Probably you charge them during the night, as most any of us do. And 90 minutes is not sufficient for one unattended night. So the 90 minutes at some point will be over. So therefore, it is very important that the cabinet can understand itself that there is a problem with a battery being stored inside. And so we use for every single cabinet that we sell at least a smoke detector that can react to the smallest amount of smoke. And depending on the model, we also use sometimes temperature sensors to also closely monitor the temperature inside the cabinet. Next slide, please. What's also important is the alarm forwarding, because consider there's a problem inside the cabinet. The smoke detector detects a problem, starts to beep, but again, if nobody is around, somebody has to be informed. And so each and every cabinet at least contains often a potential free switching contact that can be forwarded to a permanently manned building center or to whomever your risk assessment defines as the first point of emergency response. So that will ensure that no signal, not during the night, not during a Sunday, will go unheard of. Next slide, please. The last element, which is also very important, is the so-called evacuation concept. So imagine there is a fire inside that cabinet. The cabinet contains that fire. The cabinet detects there is a problem. The cabinet informs someone. So what is it that the first responders do? I mean, they also don't have this magic fire extinguisher, right? So what we enable them to do is to take the whole cabinet, the whole enclosure out of the building within that 90 minutes time frame. All of our cabinets are therefore built on a transport base, because this is what the fire brigade wants to do, right? They want to take that fire hazard out of the building if they can. And this is exactly what we enable them to do. Obviously, we don't force them to do so, but from our experience, I can assure you that most any first responders are very happy if they have the possibility to take that whole enclosure to the outside without affecting the building. Next slide, please. As Kubus mentioned totally correctly in the beginning, This is a simple sort of picture how a lithium battery looks like from the inside. When we talk about lithium batteries, normally it's a battery pack that contains of several individual cells. Obviously, you also have seen electric cars, you have seen handheld power tools, you have seen e-bikes, but probably never those individual cells. Why? Because obviously they are housed, right? So they must be protected from humidity, moisture, dust, etc., etc. So it is very difficult to cool a battery once those thermal runaway started, which is why the evacuation concept is so important, because you cannot just extinguish a battery fire like that. So the best practice in our experience is to take that whole enclosure outside of the facility. Next slide, please. Here you see the 5 pillars of the asecos safety concept again at one glance. 90 minutes fire resistance from the outside to the inside, what insurance company want to see. 90 minutes fire resistance from the inside to the outside, because it is the battery that may poses the fire danger. Alarm detection to enable the cabinet to understand that there is a problem. Alarm forwarding to ensure that somebody is alarmed even during the night. And 5, the possibility for evacuation, which again is something that fire brigades will gladly take as an advantage. So this is what we originally thought a good protection concept must address. But was that sufficient for us? No, it was not sufficient for us. So we developed a cabinet based on those principles here. But obviously, before we started selling or introducing such system to the market, we carried out our own testings. Next slide, please. As you can imagine, back in the days, there were no real battery fire testing scenario standard setup sort of for those batteries, right? This was a completely new topic. And so we developed that cabinet based on the principles that I have just introduced. And then we went to the Federal Institute for Material Research and Testing in Germany. We put e-bike batteries into that cabinet. We forced those batteries to go into a thermal runaway, and we closely reviewed the impact of a real battery fire for our cabinets. Next slide, please. In fact, we carried out numerous tests, and based on all those tests, we improved our cabinets further until we were 100% sure that this is a state-of-the-art good solution that we can, full of confidence, start to sell into that market. Next slide. And then we introduced this to our customers, and we've seen a lot of fires proving our points. You can see here fire exposure from the outside to the inside. On the left-hand side, you can see that cabinet standalone in a building, whereas there is not so much left, apparently, so from that building. So the fire there went on for numerous hours. The cabinet looks a little bit rusty. Why is that? Because obviously they used water to extinguish the fire around. But having a look into that cabinet on the right-hand side, you see that all the synthetic material of the cable, the plastic from that little sump that you have there on top, the smoke detector, etc., everything is still in a meticulous shape. And having a look at the outside and again a look at the inside, I guess we can all agree that this really is proof that the fire resistant concept from the outside to the inside does work. Next slide, please. Also here, another cabinet, fire exposure from the outside to the inside. Also, you can see cabinet has a little bit of a rusty color, again, due to the extinguishing water that has been used. But also having a look into the cabinet here, you see that the air grid, the smoke detector, the socket strips at the back, nothing, no plastic have melted whatsoever. Again, a very good proof that the concept from the outside to the inside does work. Next slide, please. Yeah, what you can see here is a picture of a fire exposure from the inside to the outside. You can see that on that middle shelf here, those individual cells that I've just shown you, right? A battery pack, basically individual cells that all went into a thermal runaway. But what you can also witness here is that on the shelf above and the shelf beyond, there is also a plastic box with even more batteries inside, and they have not been affected by that fire at all. So we can not only prove that the testing works from the outside to the inside, but we can also ensure that a fire inside the cabinet on a specific shelf will not even spread inside that cabinet to the lower or the upper shelf. So again, a very good proof of the durability of our solutions. Next slide, please. Yeah, this is always what I emphasize as the best case and worst case scenario. As you can see, obviously a fire occurred inside that battery cabinet here. So what has happened? A battery fire occurred inside that cabinet. The cabinet enclosed that fire. The cabinet detected a problem. The cabinet forwarded a signal. Fire brigade came on site. Fire brigade took the evacuation concept to heart, used that pallet truck here, took the cabinet upwards, moved it out of the building, and took appropriate countermeasures at the outside. And again, this is always best case and worst case scenario. And I assure you, discussions with insurance companies are always easier that way. It's always easier to say, I need a compensation for a cabinet, some batteries, and my chargers, instead of saying, I need a compensation for half of my building that burned down due to a fire incident with a battery. So this is always best case and worst case if it comes to that point. Next slide, please. Yeah, you don't have to count all those cabinets here. These are 100 cabinets. And based on our experience, as you can tell, from 100 cabinets that we sell, we see over time 3 fires occurring. So it's end users or dealers of ours that approach us and say, our customer or we as an end user had a problem inside our cabinet. Consider this, 3 in 100 equals 3%. In medicine terms, if a medication has a side effect rate from 3%, this would be considered as a common side effect. And I do believe that nobody of us would take any medication where the official side effect rate equals as common, right? So what does that mean for your handling and for your storage and charging situation for batteries? Keep that in mind. In medicine terms, the fires that we've seen with batteries are considered as common. Next slide, please. For us, when we developed the very first cabinet in 2019, the journey was not over at that point. We introduced that cabinet to the market, but we have seen so many fires. We monitored every individual fire very closely, had a look at the cabinet, then went back to the drawing board, improved the cabinets. So it is an ongoing process of creating a state-of-the-art concept. And when we introduced the first generation in 2019, we draw from our experiences, and in 2023 we introduced the second generation based on the fires that we have seen, and in 2025 we introduced the third generation of lithium battery cabinets to the market. Because for us it's always important to test in accordance to the very latest standards that develop as we speak, and also obviously to learn from the fire incidents that we have seen. So every cabinet that you can buy today is the best version of itself based on all the fire incidents that we have seen throughout the years. Next slide, please. Yeah, and from the very early stage in 2019, this is where we are today in 2026, having a whole family of battery cabinets. A battery cabinet for every use case, just storage and charging, small cabinet, big cabinet, small number of batteries, large number of batteries, everything available at our very, very good partner at Lasec. Next slide, please. Yeah, let's draw some conclusions coming to the very end. Well, the first one is treat lithium-ion batteries as a hazardous material, because in fact, this is what they are. Mechanical damages, thermal and electrical overloads can lead into a thermal runaway, so a fire exposure of that batteries. Thermal runaways are unpredictable. They can be rapid and explosive or slow and smoldering, sometimes even both. Most fire incidents happen during charging, especially when unsupervised. So always keep that in mind, that this is all on you. Unsupervised charging is something that the user manual prohibits. A good protection concept must address fire resistance, obviously, but also supervision, detection, and evacuation. And obviously, based on what you have learned today, risk assess your storage and charging situation and please take informed action. Well, with that, I hope this has been somewhat insightful for you. I'll now hand over the word again back to Lasec. I thank you very much for your attention. We have sufficient time now to clarify all open questions that you may have. And yeah, I also would like to thank dearly our very valued partner Lasec for giving us the stage to introduce our solution. And with that, again, thank you. And the word is back with you, Lisanne.
Thank you very much, Cobus and Marius. What a wonderful session. We have so much insight and learning from different fields in the market. What are the importance about lithium-ion batteries? I want to thank everybody for joining, taking the time again, and also to our special guests, Cobus and Marius. Thank you very much. If there's any questions, please feel free to send us an email or get in touch with your relevant sales rep to get in touch with us for any other information. Thank you very much, everybody, for joining. Have a lovely day.